So this is our second cesium chloride gradient, and you will see our plasmid band right here and a small amount of contamination that we got in there from last time, but that's why we do 2 cesium chloride gradients. If you ever use one of those kits to isolate DNA, it will say things like, gets DNA as clean as 2x cesium chloride. So this is the standard that it is referring to when it says 2x cesium chloride, that you have put it through 2 cesium chloride gradients to make sure that there's no contamination. So we still have to release the vacuum. So rather than cut the tops off this time, we're just going to use a little needle to release the vacuum. And we're still going to do the same thing, holding on to the top carefully, never holding on to the bottom, because you don't want the needle to slip and poke your hand. We're going to hold on to the top with gloves on our hands because you're working with ethidium bromide, and because you have a UV light there, you must have UV goggles on to protect your eyes. So you're going to go in a little bit below the band, and you're going to simply push it in. So you're pushing it in, and then you're going to put the beveled edge of the needle up towards the band, and you're going to start withdrawing plasmid. Always keep the beveled edge just below the level of the plasmid band because it's sucking up from above the band. Oops. So here, it's only about a little over 2 mils for us. Then you're going to put the cap very carefully on the needle, put it into the bucket, and then later put it into an approved needle disposal container. Then we're going to put it into a snap cap tube, and we will extract with isoamyl alcohol, which is an organic alcohol. Because ethidium bromide is a flat planar molecule, it vastly prefers the organic environment to the aqueous environment that it is currently in. And it will then be found with the isoamyl alcohol layer. It will leave the aqueous layer, and we will then be able to get rid of the ethidium bromide, which otherwise, if left on the DNA long term, can damage the DNA. Now we have our extracted band, and we want to add isoamyl alcohol to it, approximately an equal volume of isoamyl alcohol, but if it's a little over, that's okay. It's not the end of the world, to each one. Make sure the cap is on tightly before you vortex, or you will find solution spinning all over your hand. Now we're going to vortex. When you vortex, make sure you vortex vigorously enough so that the entire solution becomes pink. If you see a significant amount of pink in your lower layer still, that orangey pink color, and not as much pink up here, vortex a little bit longer to make sure that everything is well mixed. Once everything has been well mixed, it will generally separate, but we're going to go ahead and centrifuge it briefly just to help the process occur a little bit faster. Now that it has spun down, we can see our organic layer is very well separated from the aqueous layer. And you can go in with a pasture pipette and you can extract the organic layer. If you accidentally take part of the aqueous layer in there in addition to the organic, so you can see right here, I have some aqueous layer. It will be on the bottom, and you can simply expel it back into the tube. You're going to do this with both of your samples. Now you have finished extracting your band. You're going to add a second round of isoamyl alcohol just to make sure you've gotten rid of all of the ethidium bromide from your DNA sample, and then you're going to spin again. So after our second spin, you can see the upper layer is much, much less pink than it was before, but we're still going to make sure we get off all of the isoamyl alcohol. Might take a couple times to get it all off. If you find it hard to see the difference between the very light pink of the isoamyl alcohol layer and the aqueous layer, sometimes it helps to hold it up to a strong light. And as always, if you get some aqueous in there, you can expel it back into the tube. So once you have removed the isoamyl alcohol from the top of your aqueous layer, you're going to put it into a 50 ml tube. I've already put some 3 molar sodium acetate into our 50 ml tube. And now I'm dumping our DNA solution in. We're going to bring it to a total of 15 mils with water. You can use the water to rinse out your tube, maximize your yield, and then bring it up to 15 mils with water. So now we have an aqueous solution with some sodium acetate in it, which is a salt, and we're going to add ethanol to it. We're going to add 2 volumes of ethanol to it. So we're going to bring it up to about 45 mils in ethanol. If you add a little extra, that's okay. Under is not okay. And then we're going to cap it, and we're going to invert to mix. Make sure you invert to mix, otherwise you'll have an aqueous layer and an ethanol layer, and then our next step is putting it in the freezer, where the aqueous layer will freeze solid and the DNA will not precipitate out. So we're going to then precipitate our DNA out overnight. The reason we're doing an overnight precipitation with this one is we have cesium chloride in here. And so we need to get the cesium chloride out into the solution. But if you put cesium chloride at -80 at a temperature low enough to efficiently precipitate the DNA, the cesium salt will also precipitate out. So this one we're going to do at -20 overnight. And then our second one, we'll be able to put it at -80 or in a ethanol dry ice bath, which is cold enough to very efficiently and very quickly maximize the precipitation of the DNA. It enhances it just by a couple %, but you're trying to maximize your yield here. So you're going to do this for all your samples.